Start with adding a node 3D to the scene and give it a world environment node. Set up a new environment and change the background mode to sky. In the sky category, add a new sky and change the sky material to procedural sky material. After the world environment setup, add a new mesh instance 3D to the node 3D. Set the mesh to plane and give it a size of about 50 by 50. If you want, you can change the surface material to a darker color. Click on the Mesh tab at the top and create a collision-shaped 3D as a static body 3D child. That is the floor for our character. Add a CharacterBody 3D to the scene and set its Y position to about 1, so the character is standing on the floor. To give the character some appearance, add a mesh instance 3D and choose capsule shape and do the same for the collision shape. The collision detection will be handled by two raycast 3D. The first one is for the detection to the left, so the name should be left. The second one is for the detection to the right, so the name should, obviously, be right. The left ray is pointing behind the character on the z-axis. That means the target position should be around -1 or lower. The y-axis should be 0 for both rays. The right ray is pointing in front of the character on the z-axis. The target position is around 1. Now add a camera to the character, so it follows the player along the path. Set it up along the x-axis, so the character will be viewed from the side. For the collision detection, add a script to the player with basic movement template. Since the character will be mostly controlled by the PathFollow, the template isn't really needed and could be created as empty, but anyway, we need a speed constant and a jump velocity for the character and PathFollow progress. I set the speed to around 10 and the jump velocity to around 8. The character also needs both raycast 3D as on-ready variables. Since I forgot them at this point, I'll shortly travel to the future. After the character has both rays as on-ready variables, the Path3D and PathFollow can be added to the scene. Create a path on the Path3D node. And set the bake interval to around 5, so the camera and player can turn around the corners more smoothly. At this point in time, the root node world needs a script to connect everything. The script needs the character node and the PathFollow3D node as on-ready variables. Now an additional function handles the connection between the player and the path. The function receives one argument, the PathFollow3D node that should be used. Normally, the player would be a child of PathFollow3D, but we don't need the full transformation information, so a remote transform node is needed. The character will be added to the remote path property by getPath. The position and scale should not be updated by the remote transform, but the rotation will be updated. So let's set update rotation to true, and to have it a little bit easy later on, also use global coordinates to true. Finally, we add the remote transform as a child of PathFollow3D and add the function to the ready function and give it the current PathFollow3D node as argument. For the movement along the path, set up an input action for left and right. Those actions will be used in the process function. One if statement is checking if the input for left is pressed and if the left ray cast is not colliding with any obstacle. The other one does the same for the opposite direction. If the character should move, the progress of the PathFollow3D node must be set. In my example, I use the character's speed constant times 2 multiplied by delta. For the left input, it's minus equal to the progress, and for the right input, it's plus equal to the progress. In the physics_process function, the character and path connection needs to be added, as well as some velocity to the character. First, we add the gravity that would normally be in the basic movement script to the physics process. If the character should also be able to jump, add an input action for jump to the settings and add it below the gravity. Now the character and path will be connected. If the character somehow gets ahead, it should set back to the progress. This way both will always match. So if it happens, the character's global position on the X path will be set to the current progress of PathFollow3D. Since the character should jump, only the X and Z global positions of PathFollow3D will be assigned to the character's global position on these axes. At the end of the function, move and slide will handle the velocity changes. Let's now get back to the scene and add an obstacle to the path. For example, a cube mesh as a wall. Give the mesh a collision shape as static body child. Now let's test if everything works as expected. Thank you for watching. Don't forget to like and subscribe.